a transfer RNA. Kind of looks snakish, like a serpentine-like. It has, on the transfer RNA, it carries 3 bases. Okay, remember, these are bases. A base, 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 base. These are bases made of nitrogenous bases. Bases and acids are chemicals that react differently in water. So a base in water, a base will form hydroxide ions. An acid will form hydrogen ions. And the more hydroxide ions the base forms, the stronger the base actually is. So you think of like bleach, cleaners you use in your house, those are actually bases. So waters out, they form these hydroxide ions. When the code is read in the ribosome, it is read 3 bases at a time. So that's like a word. 3-letter words. Sounds communicate. Simplify. Right? Nature knows best. Nature's the best engineer ever. How does it know how to do this? Simplify. So, we're going to have these 3 will be read together. That'll be like a word. Then you're going to have these 3. And then I'd have, let me just add a couple more. And then I'd read these 3. They are read in 3s. 3 bases read, that's a word. So that's going to make sense to transfer RNA to make protein. 3 at a time. I'm not going to read 1 at a time, 3. That is called a codon. So these 3, this is a codon. Think of a code. Next 3, another codon. Next 3, this is another codon. So nature knows what it's doing. Nature's smart. You can't outsmart nature. I mean, look at this. So this is how it's read. So this RNA now, remember, this is the messenger RNA. And this is transfer RNA. Looks like a snake. This RNA is going to be read to make proteins. It's got to make sense of it. You've got to convert this message to proteins. So, what happens is, the transfer RNA will base pair with the codon. So the transfer RNA is going to bring 3 bases to complement these 3. However, it's not going to be the codon. Since it's kind of the opposite, it's called the anti-codon. So the transfer RNA is going to carry anti-codons. We have 3 bases, so we're going to draw them. So if we have, remember the base pairing rules, if we have a U, the U is going to match up with A, right? Because remember, there's no T in RNA. So this is like replaces the T. Remember in the DNA of AT&T? The A in DNA would match up with T, but there's no T in RNA. There's uracil, which is U. Okay. G matches C. So this is the anti-codon, AUC. So AUC. So this is called anti-codon. Anti-codon. And it's going to be carried by the transfer RNA. So here's a transfer RNA, kind of looks like a snake. It has the anti-codon for this codon. So this is not going to match up with this one. It's only going to match with that. The anti-codon.